Hello friends, today I am going to discuss about some types of the optoelectronic devices, right? Last class I discussed about the light emitting sources. Okay. Now apart from the light emitting sources there are the other types, right? Photodetector, fiber, then modulator, filter and so on. Okay. But the fiber, optical fiber, photodetector and light emitting sources, these uh, three components are the mainly important if you design the optical communication system. Okay. uh, what is the optical communication system? Here light emitting source, there is one channel, here is the photodetector. Okay, this entire system is called the optical communication system. In this optical communication system, the light emitting source that emits the light. Okay, that means the normal communication system, so we can use the copper wire in case of the normal communication system. The data that is sending in the form of the electrical pulse, but in case of the optical communication system, the data that is we are getting in the form of the optical signal. Okay, so light emitting source emits the transmit the optical signal. Okay, that will passing through the optical fiber. This is the optical fiber that will passing through the optical fiber. Then it will the information that will be received by the photodetector. Okay, in the form of the optical signal only. Okay, this is the transmitter and this is the receiver. This is the channel which is optical fiber. Okay, light emitting source that I have discussed in the last class. Today I will discuss about the fiber and the photodetector. Okay, so these three are the main important parts in the optical communication system. Okay, now is the optical fiber. Why optical communication system or optical fiber is important? In this optical fiber I am sending the data in the form of the optical. Okay, in case of the if we send the data through the copper wire, the copper wire transmits 10 million electrical pulse per second, but in case of the optical fiber it can transmit the more than 100 billion optical pulse per second, right? And apart from this, optical fiber transmit data over the long distance at higher bandwidth and the higher speed. It has the high flexibility and the high reliability. That means there is no privacy issue in case of the optical fiber. If you send the data through the optical fiber, it will not interfere with the other data. Okay. Now the optical fiber that is made up of the mainly plastic or glass. Different of the kinds of the polymers are there in case of the plastic or glass. Okay, so very thin layers are there in case of the optical fiber. There are the two main layers. One is the core layer and other is the clad layer. This is the core layer. Inner layer is the core layer and outer layer is the clad layer. Okay, the reflective index of the clad layer, that should be less than of the reflective index of the core layer. Okay, why this thing? Because the optical fiber should follow total internal reflection. Okay, now if the light enters into the optical fiber, okay, what will happen? It will transmitted towards the interface of the core and clad layer. Okay, but due to the this kind of the reflective index, it will reflect it back from the interface of the core and clad layer, rather transmitting towards the clad layer. Okay, it will reflected back from the interface, again transmitted, again reflected. In this way, this will pass towards the other end of the optical fiber. Okay, this phenomena is called the total internal reflection. Okay, now in this way, this is called the light light will propagate in the form of the total internal reflection through the optical fiber, and it will be received by the photodetector. Okay, So this is the phenomena of the optical fiber and the principle of the optical fiber. So totally entire thing is related with the reflecting index and the total internal reflection. Okay. Uh, Now coming to the photodetector. Coming to the photodetector. Okay. Photodetector means it is one kind of the sensor which can sense the optical signal and it will transfer into the electrical sensor. Photodetector means photon that should be detected by the any kind of the device or detector. Okay. Photo plus detector. Photon means light. Okay. So it is a one kind of the device. By this device the light energy that should be converted into the optical energy. Okay. Electrical energy. Okay. So the light energy that should be converted into the electrical energy. This electric energy will be give the photocurrent to the external circuit. Okay, photocurrent to the external circuit. This entire phenomena is related with the photoelectric effect. What is the photoelectric effect? Okay, so when light falls on the device, any kind of the device should be made up of the semiconductor diode. Okay, when light falls on the device, then the electron hole pairs are produced. Electron hole pairs, when the electron hole pairs should be produced, when the light energy that should be the light energy, light energy that should be greater than of the difference between the conduction band and the valence band of the semiconductor. Okay, that time the electron hole pair will be produced. Okay, so the electron hole pair will be produced. After the production of the electron hole pair, this electron hole pair should be dissociated into free carriers to produce the photocurrent. Okay, so to dissociate the to dissociation of the free carriers, we have to apply the electric field, that may be internal electric field or external electric field. So due to the application of the electric field, the electron hole pairs are dissociated into free carriers. This will give the photocurrent to the external circuit. This entire phenomena is called the photoelectric effect. Okay, light energy, electrical and electron hole pair, then the dissociation of the electron hole pair, generation of the electron hole pair, dissociation of the electron hole pair, then flowing of the electron hole pair that produce the photocurrent. Okay. Now I will discuss the working principle of the photodetector by using the diagram. Okay, band diagram. Okay, now I am drawing the band diagram. Okay, the entire PN junction. So as I told them, the photodetector that is made up of the PN junction diode. P-type semiconductor and N-type semiconductor are connected with each other to form the PN junction diode. Okay. Now, so in this when the P and N-type semiconductors are contact with each other, this will form the three different regions, right? One is the depletion region. This is the middle region is the depletion region. So along with the middle depletion region, this is the diffusion region of the N. This is the diffusion region of the P-type semiconductor. Far end of the N-type semiconductor and far end of the P-type semiconductor. Now, what is the depletion region? Here I am discussing about the depletion region. This is the PN junction diode. Okay. So at this moment, after contact, so holes are the majority carrier in case of the P-type semiconductor, and electrons are majority carrier in case of the N-type semiconductor. Okay. this hole will be along with the, in the thermal equilibrium condition, along with the hole there is a immobile or unbound negative charge is there. Okay, so when holes diffuse towards the inside region and electron diffuse towards the inside region, hole diffuse towards the inside region and electron diffuse towards the p side region. Okay, due to this diffusion, the immobile negative ion will create near the junction of the p side region, and immobile positive ion will be created near the junction of the inside region. Okay, these are the bounded, okay, or immobile. This will not produce any kind of the free carrier. Okay, these are not the free carriers. Okay, so due to this immobile negative ion and positive ion, one barrier will create, and this barrier will again create the electric field in this region. Okay, this barrier opposes the flow of current. Due to the barrier, further electron and hole will not move through the junction. Okay, so when the electron will be flow, if we apply any external bias, in this case the electron, there will be the movement of the electron and hole. Okay, so this is the depletion region. This consists of the immobile ions which will due to this immobile ion, the further electron will not move, okay, through the junction, and this barrier will create a internal electric field. Okay, now in case of the p-n junction diode, the depletion region consists of strong electric field. Okay, and in diffusion region and this diffusion region, in this diffusion region, magnitude of the electric field is less as compared to the depletion region. Okay, as there is no immobile ion in case of the p side, far end of the p side region and far end of the n side region, there will be no electric field. Okay, if we draw the electric field, that will be like this way, magnitude of the electric field. Okay, now when the light energy will fall on the device, then what will happen? Electron will transfer from valence band to conduction band and will create the bounded electron hole pair. Why it is bounded? These are strongly connected with each other. If we want to separate this electron and hole, we have to apply the strong electric field. That may be internal electric field or external electric field. Okay, so this electron hole pair will produce in the entire region the diffusion diffusion region, drift region, depletion region. They are also in the entire region, electron hole pair will be created. Okay, suppose 10 numbers of electron hole pairs are created in the depletion region. Okay, equal number of electron hole pair will be created. Okay, in the entire region. Suppose 10 numbers of electron hole pairs are created in the depletion region as well as in the diffusion region and the far end of the p side and n side region. Okay, but as strong electric fields are there, strong electric field is there in the depletion region as compared to the diffusion and the far end region. Okay, 10 number of electron hole pairs are dissociated into the free carriers due to the strong electric field. Strong electric field helps to dissociate the free carriers. Okay, this will not be bounded now. Okay, these are free. Once the free carriers will produce into the region, so this free carrier will give the external current to the external device. Okay, so 10 number of electron hole pairs are dissociated into the free carriers in the depletion region. But in case of the diffusion region, suppose 10 number of electron hole pairs are produced in the diffusion region. Here 10, here 10. But as less magnitude of electric field is there in the diffusion region, okay, so this electron hole pair will, all the electron hole pairs will not produce the free carriers. Suppose out of 10, 5 electron hole pair will produce the free carriers in case this diffusion region, in case of the this diffusion region. When it will get the electric field? When this electron hole pair diffuse towards the interface of the depletion region, that time it will get some electric field from the depletion region, but magnitude is less. Okay. So due to this electric field, this electron hole pair will be dissociated. Same case will happen in this case also. Okay. Now coming to the far end case. Okay. As there is no electric field. Okay. To get the strong electric field, this electron hole pair will be diffused towards the depletion region, and this electron hole pair will be diffused towards the depletion region. Okay. But when the electron goes from the valence band to conduction band, it has some time, lifetime. Okay. Within a certain lifetime, it has to come back into the valence band. Okay. So within this time period, either this electron hole pair will be diffused towards the depletion region, or it will get some electric field and dissociated into the free carriers. Okay. So it will take some time to reach to the depletion region. Due to this region, the electron hole pair will not dissociated, because it needs electric field. Okay. So again the electron will be recombined. Electron will come back into the valence band, and it will recombine with the hole, or it will not produce any free carriers, hence no photocurrent. Okay. Suppose 10 number of electron hole pairs are produced in the far end region. So this 10 out of 10 electron hole pairs, only the one electron hole pair will give the free carrier. Okay. So this is the entire phenomena, and after that we have to apply the reverse bias into the PN junction diode. Okay. Why we will apply the reverse bias? If we apply the forward bias, right, we will get some extra free carriers into the device. We cannot distinguish which free carriers are related with the electron hole pairs. Okay. Due to the injection of the electron hole pairs from the external circuit. Okay. Now if we apply the reverse bias, there another point is that if we apply the reverse bias, we will get the depletion region, wider depletion region, that will produce the strong electric field. Okay. So this strong electric field is required to dissociate the electron hole pairs. Okay. Again, after dissociation of the electron hole pairs, this electron, all the electrons should be attracted by this positive terminal. Once we get the electron and hole into the external circuit, that time we will get the photocurrent. Okay. This electron will be attracted by this positive bias. Okay. And this hole will be attracted by this negative bias. Okay. So the flow of the electron will give the production of the photocurrent into the external circuit. Okay. So this is about the working principle of the photodetector. On the coming lecture, I will discuss about the types of the photodetector and parameters of the photodetector, followed by applications of the photodetector. Thank you.